Good afternoon, and welcome to today's webinar, Improving Situational Awareness with Vertical Location. I'm Donnie Jackson, editor of IWCE's Urgent Communications, and I'll be your moderator today. In a moment, I'm going to turn things over to our speakers, but first let me explain how you can get the most out of this webinar, which is brought to you by our good friends at NextNav and Intrepid Networks. To improve your viewing and listening experience, you can move your webcast windows around by dragging on the title bar, or you can resize them by clicking on their lower right corner. At the bottom of your screen, you'll find multiple application widgets. By clicking on these buttons, you can open and close widgets on your screen. Several resources are available and can be accessed within the Resource List widget. We welcome questions about our topic, and we'll answer as many as we can following the presentations. But feel free to submit yours to the queue at any time. Just type it into the Q&A window on the left-hand side of your screen and hit the Submit button. Please also be aware that today's session is being recorded and will be available for on-demand viewing. You'll be notified by email when the archive is available. Now, let me introduce today's speakers. Joining us from NextNav is Deepak Joseph. In his role as Vice President of Product Management, Deepak leads the effort to deliver vertical location at scale through NextNav Pinnacle. And we also have Ben Ball, who serves as the head of marketing and is responsible for establishing and developing NextNav's brand as it brings a new generation of geolocation products to the market. And joining Deepak and Ben is Jason Winslow from Intrepid Networks. Jason is an experienced warfighter with 12 years of tactical and operational experience. Jason has been responsible for planning, coordinating, and executing combat and civil relief operations, as well as doing some foreign military training. He also has experience establishing value-driven strategic partnerships. Now, you can find out a lot more about our speakers by clicking on the speaker bio widget at the bottom of your screen. Check it out when you have some time. And with that, let's get started. Jason, the floor is yours.
Thank you very much for the introduction, Donnie. Everybody, thank you for your time. Very excited to be here to discuss our Intrepid Response to FirstNet platform, and in particular, today our integration with NextNav's Pinnacle location services. So who is Intrepid Networks? We were founded in 2011. We're headquartered in Orlando, Florida. And we're really leaders in total lifecycle user-friendly solutions that enable our customers to more efficiently communicate, collaborate, and coordinate. The main problem that we aim to solve is that we discovered upon our founding that a lot of organizations, particularly in public safety, oftentimes lacked timely and quality information to enable rapid and accurate decision-making. Hence our mantra of communicate, collaborate, and coordinate. To address this issue, we developed a platform called Response for FirstNet. Response for FirstNet is a situational awareness platform consisting of a smartphone and companion web applications. The platform consists of 4 different modules, those being Locate, which is mapping, Activate, which is a simple-to-use emergency notification tool, Connect, which is secure messaging and digital content sharing, and then finally integration with push-to-talk over LTE solutions. Locate provides live GPS positions on a Google Maps interface that will update every 5 seconds. The locations are posted from the mobile application itself, can be viewed on the mobile app, and at the same time on the web application. You can also place static locations of interest, which could indicate things like an incident location, where a roadblock is needed, and things of that nature. You can also render shapes, which can indicate things like search areas, evacuation zones, or routes. There's various other features available from here, such as auto navigation to a user or to a marker. With the integration with the NextNav Pinnacle Z-axis location, you can now view not just the XY location of responders, but also the vertical location in the format of height above terrain. Ben and Deepak will provide you an excellent overview of how that technology works and what it means to you in their presentation. This information is also visible on our companion web application, which you can access with anything with a modern browser that's connected to the internet. Activate is a very simple to use emergency notification tool. This was actually designed and developed in conjunction with public safety. In particular, some of our SWAT team customers that came to us and asked us if we could create a solution that would help them replace their outdated pagers, phone call trees, and SMS messages, which we were able to do so, which also ended up helping them save some money that they could utilize for other important things to support their mission. From the website, supervisors and dispatchers are able to select either pre-formatted groups and or individuals to alert of a critical incident. They also have visibility on who's actually accepted the notification and therefore who is responding to the incident. On the mobile side, at the user end, the users receive very persistent and loud push notifications that will continue every 30 seconds until they actually interact with the activation and either accept it or decline it. These push notifications can be set up or configured on the device to even override the device's do not disturb settings. Additionally, it's configurable to allow the Activate to send out a text message and or an email for redundant forms of communication. On the user side, they can also review critical information, such as details about the incident, as well as navigate to the location should they not know how to get there. Connect is our secure messaging and digital content sharing module that allows for very simple means of communicating messages. It supports multiple data formats, so you can upload files of any kind, including PDFs, spreadsheets, PowerPoints, images, of course, videos, all of which can be annotated in real time for a collaborative whiteboard type session. There's also the option to conduct dynamic task management, which could all be conducted digitally and electronically on the fly. I mentioned earlier integration with push-to-talk. Response for FirstNet integrates with the AT&T enhanced push-to-talk solution on the mobile client today, and stay tuned for a lot more features coming soon. All of the data within the platform can be organized into secure information containers that we know as channels. So much like an LMR network with their channels or talk groups, you can support multiple units or multiple concurrent operations at the same time. These channels can be set up by operational unit to support their day-to-day operations. They can also be set up and deployed on an incident-by-incident basis. It's very easy to move in between channels and to invite users that need to participate in your incident into the channel that you're currently in. So with that, I'd like to turn it over to the NextNav team to discuss more in depth the Pinnacle location service.
All right, thanks very much. I'm Ben from NextNav, head of marketing here. And you know, we've heard a lot from first responders over the years about why this solution is so important. Here are just you know, some examples of what NIST heard, the National Institute of Standards and Technology, when they went out and did a huge survey of first responders across, you know, police, fire, EMT, and others, and they heard very consistently across the board that this was a major challenge, you know, out there in the field. So we've been working on this technology for a really long time, and we've heard the first responder community loud and clear that this is something that's needed. And now we're really excited to roll it out. So I'm just going to go into how it works just very briefly. So if you have a smartphone that was built after around 2015, which is probably most smartphones out on the market today, it has a barometer in it, a tiny little barometer. You know, if you have a smartphone, you can probably see the vents in the bottom of the phone. That's where the air gets in to feed the barometer. So basically, we take the reading from that barometer, and then we compare that to the pressure reading in your local area. We've set up a nationwide network of altitude stations, which provides weather information, pressure information, you know, in a very localized place. And then we take the information from your device, from those altitude stations, and then we put it all in the cloud, we run it through our algorithms, and we come up with the vertical location measurement based on all of that data. We've also, so all of this doesn't require any new hardware. It's already been deployed out there. Doesn't require any, special spectrum or anything like that. It's something that your phone actually produces today. And it's already in a lot of the first responder devices that are out there on the market today. And we've worked very closely not only with the handset manufacturers, but also with the barometer sensor manufacturers to get the most accurate readings from those devices as possible. And we actually correct for the vagaries of specific devices and the sensors that go into them. So we've done a lot of work on this. And this is just a chart just to show you how the pressure can vary in a single place over the course of a day. So NextNav basically smooths out all of the anomalies that are happening in the background, and we're left with a very clear picture of vertical location as a result. And as you can see from all of the testing that's been done out there by the FCC, CTIA, our solution is incredibly accurate. The FCC requirement is plus or minus 3 meters, which is basically the same as a floor. Our solution exceeds that by quite a lot, and it has for a long time. And we're continually adjusting that, improving our solution. So we expect this to get even better over time. But this is tested, proven out in the field. And we're pretty excited about it. We are clearly the most accurate solution out on the market today, and that's why we've been selected to go out into the field first with Intrepid and with their partner at AT&T and through FirstNet. So we're pretty excited about that. Where is it available? It's basically available wherever there are large buildings in the United States. We're now in 105 major metropolitan areas, which is over 4,400 cities, and that's over 90% of the buildings that are over 3 stories in the United States. We're looking forward to expanding that market coverage elsewhere over time, but right now we cover pretty much anywhere that you would want a vertical location service. Here are just some examples of coverage areas, and with the slides, when you get those from Urgent Communications, we'll send around a link to the interactive map that you can look at to find out if you're in the service area. But right now we cover, large swaths of the country, large urban areas, and a lot of sort of smaller metros as well, trying to cover just basically where all of those tall buildings are. So now I'm going to hand it over to my colleague Deepak, who's going to talk a little bit more about the guts of this and how we can integrate this vertical location solution into other public safety apps. Deepak, take it away.
Cool. Yep, thanks, Ben, and thanks, Donnie and Jason, for the intro before. And thank you all for attending the webinar. As Ben was describing about kind of what capabilities that we have in terms of the vertical location as a service, kind of our coverage area, how the technology works. The next few slides are going to talk about how we're actually delivering the service to end users through application providers, and of course, Intrepid is a great example, as Jason outlined, in terms of how within the locate feature, there is the height element that we're providing. So our goal, of course, is to enable application vendors to have this capability to get the vertical location such that the end users can experience this. In terms of how do we actually deliver the service, especially in the mobile platform, because I think we recognize that location today, for the most part, is experienced by end users through their mobile devices. For the most part, all or many situational awareness applications, especially the Intrepid application as a great example here, use a 2D map to represent the blue dot within the map, or within the application, to kind of give the concept of where a particular user is, as well as in the use case of the Intrepid app, where let's say in a theater of operation, as a bunch of first responders are responding, you get to see different icons that place users kind of on the 2D map. So what we've done is we're working to deliver our vertical location through an SDK that could be added to these applications to enhance them to add the vertical dimension in addition to the 2D. So in many cases, what you'll see, the way this manifests itself as we are rolling out the service, is that the mobile SDK that we provide or enable is integrated into an existing application that in many cases already has a 2D map and is plotting the blue dot, if you will, and other metadata about the 2D position, but it's now being enhanced with the altitude information. In some cases, the altitude information is represented textually as an initial example, and I know Intrepid application has future features that are coming out that make it more easily understandable by end users in terms of how the vertical location is conveyed to the end user. So the way we primarily deliver this technology to app partners such as Intrepid and others is through these three vectors. So we have a mobile SDK. We, of course, we have a Unity plugin, and we have an API. The mobile SDK really is for Android and iOS devices, and it's been available for some time, which is how Intrepid used that SDK to integrate into their application. We're enabling a few other platforms like the Unity plugin for the VR, gaming, those kinds of applications. There's also APIs available for IoT and other kinds of devices, because we recognize, especially in the first responder community, while the mobile device is an important component, you also do carry other types of devices to convey the situational awareness. So from that standpoint, we have a few different methods by which we deliver our services to our partners, which then make it available to end users. So in terms of the Pinnacle SDK itself and the service that we offer, we spend a lot of time thinking about how to make it as simple and easy for our partners, such as Intrepid, to integrate the SDK and bring it to market as quickly as possible. So in many cases, we take on, the SDK takes on a lot of the actions that would typically have to be done by the application in order to generate the altitude. So in many cases, we have made it simple enough where the SDK, once dropped into a host application, the host application can tell the SDK, give me altitude, and the SDK kind of does all the background things that it needs to do to then provide the altitude. And in most cases, what the SDK is really doing, as Ben was alluding to before, is that it reads pressure from the device. It goes to our cloud service to download the assistance information from the network that we operate, and then it computes the altitude. And the way this SDK generates the output, the way we've designed it, is it provides it in kind of two formats. One is the HAE, which is height above ellipsoid, and HAT, which is height above terrain. And the reason we kind of provide the two kinds of outputs as the raw altitude reading is for the one reason where HAE is a height metric or a vertical location metric in meters in our case, that is tied to kind of a mathematical model of kind of how the Earth is represented, which is not influenced by the exact precise 2D location of the device. Whereas height above terrain is a value that is represented based on a height that is relative to the 2D position reported by the device. Because obviously, as you're carrying your devices, the device is already providing information about what that 2D position is. And based on that 2D position, we can then, using the height value, figure out, how high you are. And so in general, if you're looking at a typical, building in the US, vast majority of the buildings are roughly 3 meters per floor. So if your height above terrain is somewhere between, let's say 0 and 3 meters, you're most likely in floor 1. If you're in, 5, 6, or 7 meters, you're in floor 2. So there's kind of a implicit, let's say, conversion that you could do in terms of taking the height above terrain and inferring kind of where the user is or the user is. And of course, if you have multiple users in the same theater of operation, just by looking at the HATs, you can relatively say if a set of users are above or below another set of users, even if you don't exactly know the floor height. So that's kind of how we provide in the current format within our SDK, kind of these two kinds of outputs. In addition to this, the SDK that we already have also provides a method to visualize the altitude. So these numbers are very much like a 2D SDK where you get the latitude and longitude. So it's kind of a numerical number, which is HAE and HAT. But then there's also a visualization component. And for that, we've got this concept of an altimeter, which is a kind of a ladder or a scale type view that you could overlay on top of your 2D map to now plot relative height positions of the users within that area of operation or within the viewport of the application screen. So we've got a couple of different ways in which not only do we provide, the SDK provides an output in terms of height with these two metrics in HAE and HAT formats, but we also provide kind of a visualization method. And of course, we work with app partners to kind of figure out what's the best use case and how they'd want to represent. In Intrepid's use case, obviously, as you saw, kind of the brief screenshot that Jason showed earlier, the 2D at the moment is being represented by a textual representation on an info card on the screen. In the future, there'll be visualization and other kinds of techniques that Intrepid is certainly considering and would be layering in. In terms of how the SDK itself works, as we kind of covered, it really is using at the core of it the pressure from the device and the location, and it goes to our network to download assistance data to kind of compute the high quality or high precision altitude information. So I guess moving on. So here's a little bit more detail in terms of how the actual SDK looks, and certainly those of you in the audience that are actual developers that are folks that manage application development teams would be somewhat interesting. In terms of kind of the attributes that we provide. Certainly we provide not just the core height itself in these two formats, but we also provide kind of the relative or the associated uncertainty or the quality metric. So the quality metric tells you that, okay, even though we're giving you height at a certain number, there could be a certain range because it's a statistical estimate, just like the 2D position. And in our case, we typically produce this uncertainty factor at a 90% confidence, meaning that we are 90% confident that the height value that we have provided is within the range of the uncertainty that the SDK has generated. So just a little bit more kind of detail into kind of what our SDK produces. So moving on to the next one. So here's a little bit of a representation of the visualization part, which our SDK has a built-in function. This is the altimeter, which is the scale that we spoke about here. And we have the visualization where this particular kind of a scale view could be laid on top of an existing 2D map, because we recognize many situational awareness applications already have a 2D map. So this was going to kind of be an augmented kind of feature to show relative position of multiple users within a theater of operation. So in general, as you're looking at a viewport and you've got a bunch of folks within the 2D plane represented via icons, those same icons are also represented on this vertical bar that tells you kind of the relative position. So this is one step closer to kind of adding 3D situational awareness, because you're now able to take the vertical data, not have to kind of in your mind think about, okay, there's a numerical number, how do I interpret it? Here, there's a visual ability to kind of see the relative position of different folks within that viewport in terms of their heights. So let me go on to the next one, just a little bit more details. So obviously the SDK, we are supporting both the iOS and Android platforms. In general, from an iOS standpoint, we support the current version of iOS and the older two versions. On the Android side, as you all know, there's a wider set of devices, so we go further down on the Android OS support. And in general, our core focus and mantra here is to make sure that the integration of the SDK is as simple as possible, because what we recognize is while integrating the SDK and getting the altitude data is probably an easy step, it's really kind of how do you take the altitude data and convert it into a use case or fit it into a use case that conveys meaning to first responders and end users is kind of the heavier lift. So we try to do all that we can to provide the altitude data in as an efficient and as a simple manner as possible. And certainly those of you in the audience that are looking to play with this and try it out, we certainly welcome. You do need to go to our website to download the library files and also get a key, a trial key. So please visit nextnav.com/pinnacle to go access our SDK. And you could get started today. And as Ben was alluding to, we are in 100 markets that the network is up and running. So really, if you're in any one of those markets, not only will you be able to develop it, you'll also be able to actually do a live test to kind of experience true altitude data coming into your system or application or POC, proof of concept application that you're thinking about building. So we'd certainly welcome that. So I guess having said that, I think maybe now's the time we could switch to perhaps a Q&A session.
Okay. Hey, I really appreciate all of you. Great presentations. Deepak, before you go away, if I'm a developer, I guess what is my next step here to integrate this into some app that I may be developing right now?
Yeah, that's a great question, Donnie. So as a developer, first thing is certainly go to nextapp.com/pinnacle. There's a pretty simplistic form to fill out a few different fields. Of course, we want to know the email address to send you the information, but really what you're filling out is a request to get a key and our developer package. And the developer package that we provide it for both Android and iOS. It has the libraries that you would integrate, or the SDKs that you would integrate into your application. In addition to that, we also provide a sample app that's already built. So it's kind of to show how the SDK is used, and you can actually experience it right away without even having to build an app. So there is a sample application. There is a developer guide for each of the platforms that talk about how to take the SDK, drop it in, and how to control it to get altitude. As well as, in addition to this, we also have an altitude visualization guide that, let's say, because we think about altitude a lot and the vertical domain a lot, we have put together a guide that gives developers hopefully a starting point to think about how to take the vertical information and represent it and use it in their particular application. So we kind of have a package that has all of this, and so any one that's wishing to play with this technology or just kind of see how this could fit in their use case, we'd welcome you to go register, and once you do, we'd send you this package so you can start experiencing it.
Okay, all right. And Jason, from the other, from an Intrepid standpoint, you talk a little bit about what are the processes people go through to put this on, first responder would do to put this on his or her device? Is it something where each one of them has to reach out to you guys, or is there another method involved?
Yeah, so I completely failed to mention that currently there's actually a promotion that's available via FirstNet for your agencies. You can actually utilize the locate module with the NextNav Pinnacle location service at no charge for 6 months. So from your organization, contact your FirstNet solution consultant or account manager. They can get an order process, and we can get you up and running within 24 hours very easily. Optionally, feel free to reach out to me, and I can connect you with the proper folks and kind of take care of you in a parallel path in terms of deploying the software, getting you trained and up and running.
All right. So the individuals do not come to you guys, correct? It's going to be
typically individuals that represent their agency or the unit within their agency will approach us.
Right. Yeah, and so the frontline officers and things like that, they're going to go to the admin and not going to have to bother with contacting you guys directly.
That's exactly correct, Donnie. Yep.
Okay. All right. Question from the audience. Is there a way to integrate 800 megahertz radios if personnel do not have work-issued cell phones?
I think that might be a two-part answer. On the Intrepid side, we do have a very robust location REST-based API that allows us to integrate with other assets, including radios. We have integrations, not with 800 megahertz radios today. It's very feasible, but we have integrated with some TSM radios, as well as other GPS-type assets. We can also export the location data from our platform to other tools. I'm not entirely sure if the 800 megahertz radios have the proper connectivity to integrate with the Z-axis, so I'll turn that over to Deepak to answer that one.
Yeah,
and do they have a barometer?
Yeah. So in terms of, I guess, the 800 megahertz radios, I guess there are a couple of things, at least my understanding, having looked at it sometime in the past, is you do need to have an external accessory that adds the GPS component, because the 800 megahertz radio is the radio. And even if you use that for, low data rate communication beyond voice, certainly in general, there's an accessory that you would need for the GPS location capability or just location capability. Now, that accessory would have to be enhanced to use to also have a pressure sensor. But assuming that those components are there, it would be kind of the role of a system integrator or an app developer to take, similar to how Jason was saying, there's an API that we're working on releasing to then integrate the ability to generate altitude for that device, either locally or remotely on our servers. So we kind of support both models, but this would certainly include both ensuring that the 800 megahertz radio has the right companion accessory, as well as the accessory now having the right software to be able to access it. So there's kind of like a two-step process that we'd have to work through. At the moment, though, really our SDKs are primarily geared for the Android and iPhones, but certainly, as Jason was also saying, from an 800 radio perspective, it would be the accessory vendor that would want to, let's say, work with us to integrate the Z capability in addition to 2D, for example.
Okay. And that actually answers one of the other questions from the audience there, which was, do you have a web API where I can submit lat long barometer and get back an HAT value? The answer is that's what's coming in Q2. So coming very soon, we will definitely have that capability.
Okay. But does the device definitely need to have the barometric sensor capability
Yes.
to be able to work with this?
It does, yeah.
Okay.
And to one of the questions from the audience, if an IoT device also would need to have a barometer. Sorry, go ahead, Deepak.
Yeah, Ben, I was just adding that because our altitude or vertical location service is a pressure-based service, we do need, in order to locate a particular device or a person carrying a device, so to speak, that particular device needs to have a barosensor so that we can read the pressure off of that device to know what the surrounding environment looks like, to then convert it into a height number using our reference network. So having a pressure sensor is key and essential to experience our vertical technology.
Okay. And so what you were saying, Ben, is that this can work with an IoT device, but it's got to have the right sensors and the right connectivity.
Exactly.
Okay. All right. Well, so one of the things, that people have been excited about is, okay, great, I've got this height information, and as a number, I didn't, how do I translate that into what it really means to the person on hey, this is the second floor, the third floor, et cetera. I'm kind of curious, has anybody started to map any of these buildings already? And I know that used to sound like an incredibly daunting task. I have seen some LiDAR demonstrations that looked like, hey, at least there's a potential path forward. I was kind of curious what you guys were seeing and how far away are we from being able to see 3D maps and the guys moving around and things like that?
It's a good question. Deepak, you want to take that one?
Sure. Yeah. So certainly we, Donnie, as we were alluding to before, certainly think a lot about how to both represent vertical data and also represent it in the context of a 3D building visualization, right? So there's kind of two aspects to it. So our first attempt at visualizing vertical location is this Altimeter method, where even if you don't have the building information, you could still relatively quite visually easily look at where the different users are located. So that's kind of like the first order, if you will, solution that we already have within our current SDK. In terms of making the building visualization, to represent it as a 3D building and then to have the dots to move around within the building, we have got a few different, let's say, platforms that we've worked with, and we've kind of created solutions around it. In terms of just the building data, there's a few different data sources. Certainly, as you said, some of the folks in the industry are doing extraction from LiDAR data. Several folks in the public safety community obviously have that kind of information from either the annual fire visits or county data. So there's a few different, let's say, sources of such information. And at least the way we're looking at it is, from our perspective, is really to create the platform that folks can bring their own data. In some cases, we have the data, but it would be kind of a mix of this kind of information that allow us to kind of extrude the shape of the building. Now, there's more detail there. In many cases, what we find is data that's available today either has just the overall height of the building or number of the floors. In many cases, the exact height of the floor is not known yet. But I think as the ecosystem is evolving, there's a range of vendors and players, and as the use case evolves and you actually now see that we're able to generate a precise vertical location data representing that vertical location data using this, higher fidelity building data as a whole industry is also going to take off. And we're seeing a lot of movement there in a few different directions. Some folks are trying to do it algorithmically by extracting existing data. Some folks are doing it by actually collecting the data. Of course, city governments, municipalities, there's also the governments themselves have some data because of permits and other kinds of things. So it'll be kind of a mix of some of these 3 or 4 different data sources, which will then allow us to use it in a platform to then render it for each agency or public safety use.
Okay.
Yeah, and then Donnie, on the Intrepid side, this is definitely something that's on our roadmap and on our radar. We're working closely with NextNav and our partners at AT&T to address this. In terms of the response for FirstNet platform, you'll definitely, as Deepak alluded to, you'll see some iterative releases that are working towards solving this very unique challenge. I do think this is a tremendous opportunity for us in the industry to really come together and solve it through partnerships, and then of course ultimately leading to providing true mission critical capability for our first responders.
Okay, all right, very cool. Well, I'm looking forward to seeing it. I'm waiting for the day when we see all the holograms and things like that with guys running around. So in terms of integrating with other applications, had some questions from the audience. Does Esri partner with NextNav? And also, is this something that can be integrated into my CAD?
Yeah, great question. So the core of what we are providing here at NextNav is that SDK that generates the altitude data. So once the altitude data is generated, that could be represented really on any platform. Right? So Esri, Google, Apple, here, TomTom, really any map SDK can take this altitude and really render on it. So the rendering portion is kind of a step above the core service that we provide. So the core service that we provide is the SDK that really generates the Z for a particular 2D, especially if it is a height above terrain type number. So we are using the 2D, so we are assuming the 2D is already there, and for that 2D we are generating a height. So that 3D location data is available to any application once it comes out of the SDK, and now it's the application's use case, whichever platform that it decides to use for whichever pertinent use case to represent and render that information. So certainly, if there are questions about whether it's Esri or any CAD system, of course, all of those platforms would have to be now enhanced to add this data, but the data itself is coming out of the SDK, and once the data comes out of the SDK, really how it represents is really up to the use case and the particular product offering.
Okay. Do you know of any CADs that actually have a slot basically for Z field so that they have a place to put this information?
Not that I know of. In terms of has any CAD, is there a released product of a CAD that has integrated the Z yet? Not that I've seen yet that come out, Donnie. I guess maybe that's how I'll position it. Yeah.
Okay. But it shouldn't be, it's just another field, right? It shouldn't be some science for these guys, right?
That's exactly right. So if you're already, if a CAD is already plotting the XY, which is the latitude and longitude from a 2D perspective, really this is one more attribute of height. And now you have now decide within the CAD, do you use the altimeter method or do you want to do a building extrusion? There's a range of options, or even the textual, right? You can start off on day one very simplistically by saying, okay, here's the number of the height, so to speak. Yeah, so that rendering is pretty straightforward in the sense that it's almost a single data element that's added to an existing system.
Okay. I have another question from the audience. We've been talking about going up in buildings, and that's always the thing that everyone talks about, but does Z-axis also go underground for parking levels and basements?
Yes. So in general, our z-axis works wherever we can get a good pressure measurement and location measurement, because really we're trying to provide height for a given location. So in that sense, you could go below grade and it will go negative. So the HAT would be a negative number. So if you go above grade, HAT is a positive number. So as long as you're kind of in the a place where the SDK can read the pressure data off of the pressure sensor of the device. In this current case, let's say an Android or an iOS device. And of course, we also need the location because we are reporting height for a particular location. As long as those are there, whether it's above or below grade, our solution works.
And I can speak to that from some personal experience here. I actually went into San Francisco last week and tested it myself in a 4-story parking garage that went down 4 stories, and it worked like a charm. It actually showed my height below grade very accurately. I was down in the bottom of a BART station, probably again about 4 stories down, and it showed me exactly where I was. And actually, when I took the escalator up to the mezzanine level, it showed me very accurately going up, to that level as well. So it definitely works.
Okay. Well, and that's one of the other questions that we have from the audience. Just how accurate is this? Is this something where I'm going to be able to follow somebody foot by foot? I'm going to know what door they're standing in front of, on which floor, or should we be tempering the expectations a little bit here?
I can take that one if you like. It really depends on how the application it actually uses the SDK. Most of them, like the Intrepid response app, query every second when you have it open and are actually using it. So you'll see that the HAT value is constantly changing. Actually, it's always looking for the latest version of where you are and constantly reading that barosensor to find that out. So it can provide very accurate, very real-time information as long as the application has set it up to do it that way.
Okay. And is this, one of the other questions from the audience is, what's the difference between HAT and the elevation reported by location services, say, in a mobile OS?
That's a great question. So in general today, if you're reading off of the iOS or the Android platform, they do report vertical location. That location is reported in LMSL format, which is local mean sea level. So obviously, then there's the conversion that has to happen between local mean sea level to something that's more relevant to kind of where the user is, which is why in our SDK, the way we report it is height above terrain, which is relative to the location at which the device is reporting. So if the device says that in Ben's earlier example, he was in the BART station, so the heights were relative to his location in the BART station. So it's not relative to a mean sea level that is somewhere else, and you could be at a different height relative to the mean sea level, right? You could be further inland and things of that nature, or the contour of the Earth can obviously change. So in our case, the Pinnacle SDK's output of about height above terrain takes into account the 2D position of the device, and relative to the terrain of that 2D position, we report if you're X meters above or below, as the case may be. So that's the difference. And of course, there's also the accuracy difference in the sense that as we've proven through multiple tests, the accuracy of our solution is much higher than what you would typically read off of a platform vertical location. Okay.
And I know you guys are covering 90% of all the all the buildings with 3 stories or more. And so public safety wants it everywhere. So are there plans to get to that other 10%? And also, is there any, can I get any kind of Z-axis outdoors through this?
Yeah, so in terms of expansion possibilities, those are definitely out there. If you're interested in this, and it doesn't happen to be in your area, I would say talk to your FirstNet representative. And then they can, interface with us, and we can, work on expansion to that market. What was the second half of the question again?
Is there any kind of Z-axis information for, how high I am up on a mountain? I would assume there's no beacons out there, but I didn't know if there was any plans, or even would I even know if a window washer or a firefighter's, on the outside of a building, if we would know where they're located, and that sort of thing, in terms of trying to look at it from a control room standpoint.
Yeah. Oh, yeah. It definitely works outdoors. It'll find your relative height just wherever you are, whether you're in a building or outside. So actually, there are quite a few industrial safety applications for this kind of technology as well. The window washers is actually a really good one. I hadn't even thought about that. But there are other sort of so-called lone worker issues. For example, cleaning staff who are in a large hotel trying to figure out, where those people are, make sure that they're still okay, they've moved in the last little bit, that kind of thing, making sure that someone in an industrial plant doesn't wander accidentally into a sensitive area or an area that's dangerous. That's another application for this technology.
Yeah, so just to add to that, Donnie, certainly our solution is within our service area for sure. There's no limitation. It's not an in-building solution. So it's not, even though we report our coverage in terms of statistics by saying we cover 90+% of 3+ story buildings, that's not to interpret that it only works within those buildings. It's actually within our service area. And I think Ben was earlier showing kind of the map, and you can certainly go to nextnav.com to kind of see the service area. So anywhere within that service area, we're able to report altitude. So outdoors or indoors are just fine, and even underground.
Okay. And public safety always has to work in the weirdest of circumstances, typically. And first off, this whole technology is based on these beacons that NextNav has. How durable are the beacons? I mean, is there any concern of, hey, a storm or lightning strike or anything like that could disrupt their ability to work?
Let me just clarify one thing, that it's actually not a beacon. It took me many months to learn this, but actually the altitude stations don't transmit anything. They're just measuring the pressure at that particular place. So just to make that clear, but I'll send the rest of it over to Deepak.
Yeah, so in terms of reliability, Donnie, and certainly for the broader public safety audience here, this is something that we think and spend a lot of time about in terms of maintaining a high availability of our service. And that actually starts at multiple layers, right? At the highest level, when we do the network planning, there is redundancy built into the system. So it's not like if one unit goes out, that entire area that is served by the unit is affected. There is actually overlap and redundancy in terms of kind of coverage of these stations. There is, of course, the concept of our ability to quickly replace a unit. So there's the whole concept of how we can handle it. There's multiple layers to kind of us doing this in a method where we provide this high level of assured service from a reference network standpoint. So we're certainly taking all of those into account. But of course, there can always be large-scale outages where there's a huge issue and the entire power grid goes down, right? So that's a different kind of a problem. But certainly in terms of localized or to the extent of the variables that we can control, we've taken a lot of care to make sure that it's a highly available service.
Okay. And low E glass can really limit the ability of a phone or a signal to get in or out of a building. Does it impact the ability for people to transmit, hey, here's my barometric pressure, here's how high I am?
Yeah, good question, Danny. So in general, because our SDK and solution is running within a phone, it really depends on how well the phone is doing in that environment. In the sense that if the phone doesn't have a data connection, then that's an issue. Or has a very low or intermittent data connection, that's certainly an issue, because a lot of the applications here, not only are you trying to figure out the height or even the location, you're trying to send all this information to a command center, for instance. So not having a good data connection is certainly an issue. Not having good location, because if you don't have a good location estimate, because then you're not even in this building, you're 3 doors down or 3 blocks down, then the HAT will also represent what it thinks is relative to the reported location, because what we are trying to do from an SDK standpoint is taking from the phone the pressure, the location, and then computing the height for that location. So if the location itself is bad, then the height will be correspondingly bad because it's built on top of the location that was reported by the phone. So certainly how the phone is doing in any environment will impact kind of how the Z outcome happens, because at the very least, you need a few of these parameters. You do need a good, reasonably functioning data connection. You need to have a reasonable fidelity of your 2D location. Some of those things have to be there as, let's say, necessary preconditions for the Z service to function.
And okay. Let me just address some of the questions that I'm seeing in the chat about sort of edge use cases.
That's where I was going next.
Yeah, about caves and about pressure in buildings and things like that. Again, as Deepak says, if there's there are several elements that go into creating an accurate reading. One of those is signal. One of those is, being able to get a pressure reading. One of those is being able to figure out the horizontal location so we can actually, make that calculation correct there. So there are some areas where, it might need a little bit of help. There are some areas where we haven't tested yet, so we don't really have a good idea about how it would perform in some of those cases. I'll just emphasize this is a relatively new service that we're rolling out. It's been tested a lot of different ways, but there are thousands of scenarios that could impact how this works in the field. And we're going to be learning a lot about those, as we go along. But we've tested in a lot of different areas, and it's a very robust solution for the vast majority of the use cases that are out there.
So are you telling me, Ben, that no one volunteered the building and said, hey, blow out a few windows, set it on fire, and have the system go off so that you find out just how that changes the barometric pressure in those situations?
Well, there actually are places where one can do such a thing. And unfortunately, a lot of them have been closed down because of the pandemic. So we are looking to do a lot of those tests, but those have been delayed just by events. So certainly something that we're paying very close attention to. We get that question, quite a bit. So.
Okay, but the reality is those kind of things can change the barometric pressure, and you all are expecting situations.
Yeah, absolutely.
Okay, all right.
And also the associated thing, Donnie, that goes with it is in these extreme conditions is setting aside the barometric pressure itself as a variable. Can the devices themselves operate optimally? Meaning that under these high stress situations, can the device, sustain that data connection? Can it give it the location? Can the electronics of the sensor function to give the data? So there's a lot of other things that also have to be taken into account in these types of extreme cases, and those are the things that Ben's alluding to in terms of us looking at.
Yeah, and I see some other questions about other edge cases like hurricanes and microclimates and things like that. Those are things that we actually can account for quite well with the weather stations that we've got out there. And we've done a lot of testing around that and have actually made quite a few adjustments in how we deliver the service just based on the weather information. We've actually had to adjust where the stations are in various markets just depending on the microclimates and things like that that occur naturally in those places.
Okay. And Jason, an Intrepid standpoint, if somebody loses connection, how does that show up, on the Intrepid app? And am I going to just get whatever the last point we saw them, or am I going to get kind of a signal saying, hey, this is the last point we saw them, but we haven't heard from them. We haven't gotten a ping for a while.
Yeah, we do have a feature built in, and the feature is what we call stale connections. So if a device is not able to make the handshake with the server after 5 minutes, visually on the map, their icon and other information will kind of gray out, and the data will become italicized. And you'll, of course, have a timestamp of the last known location. So you will have, a last known location to go look for someone. That hopefully, heaven forbid, nothing went wrong. We haven't had a customer need to utilize that feature yet, but it is available.
Okay, all right. And then in terms of, there's a question here about, hey, does the FCC play any role in this? And I guess I would also piggyback onto that and say, hey, you guys are working with the government, a government entity and FirstNet. Does this mean that NextNav is necessarily going to be the answer for 911 location that the FCC is considering?
I can take that one. In terms of the the FCC's involvement, they've created the standard for vertical location accuracy, right? So a while ago they said, okay, plus or minus 3 meters about a floor height is what we want. What first responders have been asking for. They've probably been asking for things that are even more accurate than that. But this is sort of the baseline that we think is possible. So that's really the target that we've been going after all of these years. And that standard was set for 911. So that's something we've been aiming at. We're working with the carriers right now to address that as part of a 911 solution. So I guess the answer is watch this space. It's something that we're clearly working on to meet that FCC requirement that's out there.
Okay. An interesting question here. Does the solution require any interaction? For instance, is there some kind of calibration needed before I go and enter this building?
Yeah.
Would you like me to take
that one?
Sure. Yeah. So Donnie, the short answer is yes. The barosensors do have just like the gyroscopes and compasses on any device, right? Like, so just like how any sensor works, the barosensors do need to be calibrated for them to provide the level of accuracy that we're looking for. So the SDK itself actually enables two methods to kind of do the calibration. One is if you use the SDK often enough, we are able to collect some data to enable the calibration kind of in the background. But if you are not using the device as often or you want instant high performance, we also have what is called as a manual calibration step. And as a matter of fact, we have, within the SDK also built out kind of the suggested screens for developers. And I think Jason can probably speak to it a little bit more, but there is that option available. So we kind of have two methods, kind of one, which is kind of if you use the application, because the issue with the barosensor is that it's well known that it drifts over time. So every so often you need to kind of, correct it or calibrate it. So we kind of have two methods of kind of facilitating that. One is kind of a background, as part of the SDK operation, and we're able to do if we can. If you're in a hurry and you need really high precision right now, you can also do this manual method.
Okay, and how long does that take to do that calibration typically?
So the manual method is 30 seconds at the moment.
Yep, right. And then in the response for FirstNet application, I mean, if the SDK tells our application that the baro pressure sensor needs to be calibrated, you do have the option to disregard it for the time being. Obviously, we're not going to expect a responder to stop what they're doing in order to calibrate it. It doesn't mean that the data is going to be inaccurate necessarily, but you are able to go back later and, to Deepak's point, manually calibrate it. It's a very, very easy process. And in fact, their SDK provides a very nice wizard that walks you through step by step what needs to happen. It's very simple.
That's a really good point. I guess, right now, people get X, Y, and the people go in the building and they really don't have any idea where they are. And what you're saying, if I understand this, is that even if I'm not super calibrated, maybe I'm not exactly precise as I would be if everything was ideal, I'm still going to know, hey, he's in the southwest corner of the building and he's probably between floors 2 and 4, which is miles better than what we have today. Where, okay, they might be in this building and they could be anywhere on these 26 floors.
Yep. That's correct. Yeah. So it's kind of a calibration allows us to tighten the performance. So even if you don't, and to Jason's point, while the SDK says in an abundance of caution, the SDK to deliver our 1.8 meter, 80% kind of our accuracy metric, we request that. But again, to Jason's point, it doesn't mean that just because the SDK says it, you need to immediately do it. And if you still continued with it for the next day or two, it doesn't mean that you'll be that far off. It still bounds the range of heights within which a particular device would be. Yeah, that's a great insight, Donnie.
Okay, and that would go for some of those edge cases too. At least you have some idea what quadrant of the building they're in, even if you don't necessarily have the barometric pressure and can say, hey, they're on the 3rd floor or whatever.
Yeah. That's correct. Yeah, that's a great point, because our goal, at least from NextNav's SDK service delivery point, is we have this very tight accuracy metric that we're trying to meet, which is that kind of that 1.8 meters 80% of the time. So a lot of the decisions that we're making is with that concept in mind, but that doesn't mean that the output of the SDK always, if you don't do all of those things, is automatically. It's not kind of a binary thing. It's kind of on a curve of, over time, you may get slightly not so good performance, and of course you can calibrate it to get better. So that's kind of how we view it in terms of performance, which is also the reason why when the SDK outputs the height metric, we give out the uncertainty number that kind of tells you the range within which the numbers could lie. And over time, those ranges could increase, and then if you calibrate it, it comes back. But again, it's not like an immediate imperative that it has to happen.
Okay. I'm going to get in one more question here from the audience. For fire guys, fire panels are not always known in large buildings where they are. Does NextNav or Intrepid have any capability to guide personnel where these panels are located?
I'll take that one first, if you don't mind, Deepak. We have a lot. So out of the box today, the answer is no. However, on our fairly short-term roadmap, we are working on a solution to address the locations of things of interest, such as fire panels. By example, in a very near future release, you're going to be able to place markers on the map, which you'll be able to also add a height above terrain. Additionally, moving further down our roadmap, you'll be able to do things like import markers in bulk. Same with shapes. And eventually we're going to get to a point, with 3D visualization where you're going to be able to even import floor plans or blueprints with, something like a georeferenced PDF that will enable you to essentially, dead reckon to the locations that are marked on those blueprints. And as you're probably aware, fire panels and FDC panels are always on the architectural or engineering plans. So, long and the short today, no, but it's something that we're working on and iterating with future improvements.
Okay. Yeah, you mentioned some of the dead reckoning and that kind of technology. Are you all able to also leverage some of the Wi-Fi location stuff when the power is on and everything's working, or any of these other location technologies to help home things in even closer?
So both Android and iOS, or I should say Apple, have done a pretty great job at mapping and triangulating based on the data, Wi-Fi hotspots and Bluetooth beacons, especially in public spaces. So natively, your iPhone or your Android utilizes that information. And in fact, we encourage our users to keep Wi-Fi and Bluetooth turned on. You don't necessarily have to be connected to a device or to a network, but that enables the device to take advantage of that additional assistance to provide a more accurate XY location, which in turn will provide you with a more accurate Z location. And with the release of Android 11, we even have the option to turn Wi-Fi and Bluetooth scanning on without the need to turn on your actual Wi-Fi or Bluetooth.
All right. Deepak, Ben, you all want to add anything to that?
Yeah, very similar to what Jason is saying, Donnie. Sorry, go ahead, Ben. Go for it.
No, go ahead. Go ahead. All you.
So I was going to say, Donnie, as Jason is saying, really the platforms, as Jason is saying, are doing a great job of using a lot of the sensors that are already in the platforms to kind of make some of these determinations and providing, APIs. So for the most part, that is very similar to the Intrepid app. The SDK also uses the standard available platforms, whether it's the iOS APIs or the Android APIs, take advantage of things like the sensor and the activity and things of that nature to provide a better estimate of the altitude using the 2D position. So we're certainly taking advantage of what the platform offers.
All right. Ben, do you want to add anything?
Nope, I'll leave that one to the experts.
All right. Well, hey, I'm afraid we've run out of time. I want to thank our speakers, Deepak Joseph, Ben Ball, and Jason Winslow for their informative presentations. And definitely want to thank NextNav and Intrepid Networks for making today's webinar possible with their sponsorship. As a reminder to everyone in the audience, you will receive a follow-up email that will include a link to view a recording of today's presentation. So if you found this event useful, please share it with your colleagues. And once you leave the event, a short survey will pop up in your browser window. We'd appreciate it if you would share your feedback on this event, as it helps us provide you with more content that is most interesting to you in the future. And I really want to thank everyone in the audience. We got a ton of really great questions, and really thank you all so much. And again, can't say enough. Thank you again to NextNav and Intrepid. I've been covering this space for the better part of 2 decades, and I can tell you from day one, you talk to the people in public safety, and their whole job is to stay cool under pressure, and they speak with incredible calmness, even in really tough situations. The one time you hear a real change in their voice is when one of their people is in a building, needs help, and they're really not sure where they are. And it's a totally different world. And there's a reason why these guys refer to this technology as the Holy Grail. And so thank you all for creating a solution. I know it's got to be very welcome in the public safety arena. So anyway, on behalf of IWCE's Urgent Communications, have a great rest of your afternoon, everyone. Thank you.
Thanks.
Thanks, Donnie. Thank you, everybody.